What up, everybody? UziNets here. Today is my 10th episode of my computer networking series, and today I'm going over remote access and NAT. Remote access is pretty self-explanatory. It gives you the ability to access a device remotely. There's two types of remote access, Telnet and SSH. Starting with Telnet, this was the first remote access protocol. It gave people the ability to configure devices, troubleshoot, test connections remotely. However, it was very bad for security. The data wasn't encrypted, so eventually they switched over to SSH. SSH stands for Secure Shell. It's also a remote access protocol, but it's a secure protocol because data is encrypted. So you can do things like testing connections and troubleshooting, but you can also do things like file transfer, tunneling, remote logins, etc. One thing Telnet and SSH have in common is the use of VTY lines or virtual terminal lines. These allow simultaneous access, which essentially means that more than one person can remotely access the device at the same time. And with the use of VTY lines, you can apply security protocols with ACLs, passwords, things like that. And here's a little side-by-side comparison of the two. You can compare and contrast. The main thing you should take away is that no one really uses Telnet anymore, mainly because of the security factor. SSH uses security encryption, and because of that, everyone's going to use SSH nowadays. Okay, you guys, now I'm going to show you how to configure Telnet. I have a simple setup with a PC and a router. So far, I gave the PC an IP address. I linked it to this default gateway, which I gave to the interface on this router. I gave the router a host name, and now I can go ahead and type these commands. So for my example, I'll use ip domain-name uzi.com. I'm going to type in username Uzi, password Uzi123, which is this command. Now I'm going to type in line vty04 and click enter. Now we're in the config for the terminal line. I'm going to type in password and the password I just created, enter. Now I'm going to type in login local and enter that. Now I'm going to type in transport input telnet. Now I'm going to go to the PC. Now I'll type in telnet 192.168.10.1, which is the default gateway. It's going to ask for a username. I type in the username I created. It's going to ask for the password. I type in Uzi123. And now, as you guys can see, it's showing me the interface for router 1. But here's the thing. If I type enable, it's going to say no password set. So now I'm going to go into the router and I'm going to type in enable password Uzi123. Now I go back to the PC, go to enable, now type in Uzi123. Now you can see I have access to the router. So just to show you, I'll type in show run. It shows me all of the running configurations on the router right there. IP address 10.1.2550, that's the interface on this router. You can see it from your PC, which is really cool. If I type in show IP route, it'll show the routing table. I can configure the terminal, I can go into the interface. However, one thing you want to stay away from is shutting down this interface, because once you shut this interface down, you'll lose connection to the router. So that's Telnet, a very cool remote access protocol. Enables you to access routers and switches from your home device. But like I said before, it lacks a lot of security features, which makes it really obsolete in today's computer networking world. So now we're going to configure SSH. This is the same exact setup we just had, same IP addresses and everything. I just removed the old commands and now we're going to add the SSH commands. So I go into the router, I'm already in config mode. So this first command, IP domain name website-name.com. I'm going to run IP domain-name uzi.com. Then I'm going to run username Uzi, password Uzi123. Now I'm going to type in this command, crypto key generate RSA. Now it asks how many bits in the modulus. It recommends 512. You can also do 1024. For this, I'll just type 512. And now it is generating the key. So now I'm still in config mode and I'm going to type in our old command, line vty04. And now I'll type in transport input SSH. Now I'm going to do a login local. And now just to verify, I'll use this command, show IP SSH. And it says right there, SSH enabled. So now I'm going to go into the PC, command prompt. This is the command to get remote access. SSH space -1 space the username space the router's IP that we're connecting to, which is 192.168.10.1. And I'm going to click enter. It's asking for the password, so I type in Uzi123, enter. And now we're accessing the router. I'm going to type enable. And then once again, it says no password set. Back to the router. And I'm going to type in enable password Uzi123. Now I'll go back to the PC, type enable again. Now type in my password Uzi123. And now we have access to the router with SSH. So now I'll just type a show run. There's the interface information for the router. Show IP route. There's the routing table for the router. And that is how to configure SSH. Very similar to Telnet, but way more secure, way more used in the modern era. But regardless, it's a very cool protocol that gives you the ability to remotely access routers and switches from your home device. Now we move on to NAT, which is network address translation. What this does is it maps private IPs into public IPs. So what that means is when you're in your local area network, say you're on your laptop, once you go to the internet sees your IP as a public IP, which means it masks your private IP at the default gateway, and then it shows a public IP to the internet. And since it masks your private IP, this enhances the overall security of the network. And also it allows multiple devices on a local area network to share one public IP. So for example, you, your phone, your laptop, your brother's phone, your sister's laptop, all these devices, when they hit the default gateway, are given a public IP for the internet to see. And right here we have the private IP address table. In case you didn't know, these are the ranges of private IPs one can have. Anything outside of these ranges is going to be a public IP, which is usually something that was bought by a company, a conglomerate, something like that. But these are the ranges of private IPs. And right here we have a little NAT diagram so you can kind of understand better. We have our end devices here on the left in the 174.122 network. They hit the router at the default gateway where they still have the private IP address 174.122. Then with NAT, it's able to mask the IP and turn it into 244.4611, and then it hits the internet. And the main point of all this is for IP conservation, because especially before IPv6 was introduced, there were only so many IPs you could have, and this made sure the amount of IPs weren't being oversaturated. And here's just some more information about NAT, the advantages and the common applications. It enhances security, network address flexibility, simplifies things, common applications, home networks, corporate networks, very useful protocol. So now we get to the types of NAT. You have static NAT, which is one-to-one mapping between a public and a private IP address. You have dynamic, which kind of does the opposite. It maps private IPs to a pool of public IPs. Not sure why you would want to do that. And then you have PAT, which is a many-to-one mapping, and it does it over different ports. So instead of explaining further, I'm going to show you in Packet Tracer how to configure these. Now we're going to configure NAT. This is my setup. We have the local area network in blue and the wide area network or the internet in green. These are the commands. They're pretty simple. You go on the middle router and you type in IPNAT inside for the inside interface and IPNAT outside for the outside interface. This PC has already been configured with an IP address. The routers have been set up with interfaces and IP addresses on the interfaces. A static route has been set up from router 2 all the way to the 192.168.0.0 network. Just to test, I can ping this PC at the end, and the ping works. So now to show you how NAT works, I'll go to the middle router. I'm going to go on the inside interface, which is gigabit 000. So I go into the interface, and I'm going to type in IPNAT inside, and click enter. Now I'm going to exit, go on to the opposite side interface, which is gigabit 001, click enter, and now I will type in IPNAT outside. Now I will exit and go into general config mode, and I will use this command. And this is the final command, IPNAT inside source static, because we're doing static NAT here, 192.168.10.2, which is the private IP at the end device, and then 124.52.25.2, which is this router's public IP address that the internet will receive. I'm going to click enter. Now I'm going to end and type in show IPNAT translations. And right here it shows us the NAT table. Actually, I'll run some ping tests first. I'll ping the default gateway. I'll ping the public IP. Those went through. Now I'll go back to the router and I'll type in that command again, show IPNAT translations. And now you can see because of the ping requests, there's been more data added to the table. And as for these headers, inside global, inside local, outside global. Inside local is just the IP at the end device. Inside global is the public IP address showing the internal device to the outside. Outside local is the external device's IP as it appears on the internal network. And outside global is the public IP of the external device on the internet. Kind of confusing, but that's the gist of it, and that is how you configure static NAT. As for dynamic NAT, it is not often the case these will be configured. Not many times in real world scenarios will you want public IPs to be turned private. So what we'll do now is move on to PAT. This is going to be our setup for PAT. By the way, PAT is port address translation. Same setup as last time, except now we have 2 more PCs at the end, connected to the switch, which connects to the router. The pings are working between the end devices and this end router. The interfaces are up. They've all been configured with IP addresses. There's been a static route set up from router 2 to the 192.168.0.0 network. So now what we'll do is go back to the middle router and we'll do what we just did for NAT. We'll set up IPNAT inside on this interface and IPNAT outside on this interface. We'll enter into gigabit Ethernet 000, IPNAT inside, enter. Now into gigabit 00/1, and we'll configure IPNAT outside. Now I'll go into general config mode, and I'm going to create an access list. I'll type in access-list1 permit 192.168.0.0 with the wildcard mask, and I'll enter that. Now what I'll do is run this command we have right here. And this is the final command, IPNAT inside source list 1, referring to access list 1, gigabit Ethernet 00/1, which is the port of the outside interface, and then overload. And we're going to enter that. Now I'm going to run some ping tests. Ping that. I'll ping that. Now I'll go back to the middle router, show IP NAT translations, and then we have our NAT table. Inside local, you can see which PC sent the ping request. On the left right here, this is the public IP address that is sent out to the internet. Outside local and global, we went over these. And that right there, you guys, is how you configure PAT. And that's it for this video, you guys. Thank you for watching. Today we went over NAT and we went over remote access. Very informative stuff. Hope you guys learned something. I will see you in the next video.